We can now start the Q&A session for the three speakers. I think, okay, so on the chat, we have one question already for Damien. So from Perry Esguerra, referring to slide 16, how well does the violet curve fit to an arc sign?
Thank you for that question. So Dr. Esguerra is referring to our plots for the waiting times as we vary the stop placements. I think I should probably share my screen again. So what we don't exactly have analytical calculations for this plot. This plot was obtained from experiments, from simulations. There is a possibility that it could look like a very squashed arc sign, but we haven't actually fitted it to that function yet. But thank you for that suggestion. I hope that answers the question.
Yes, it does. So let me share a couple of, you know what, being the host, I have the privilege of asking questions. So let me show them now. So for Reina, how would the cross-border limits that we're now seeing affect the results of your simulations?
Very interesting. Yeah. To be honest, I haven't really given much thought, but I had the idea that there are interesting scenarios to be considered in the current situation we're in. I guess top of mind would be there would be additional delays due to checkpoints between borders, so that would add up to the travel time, and parang this has been an issue that we've encountered, of how do we keep the flow of goods freely free while of course gaining the benefit and restricting mobility of people who are not supposed to be traveling. And I think it would be interesting to look into that. For the airports and seaports, I think definitely much reduced trips, and so the model does not currently consider like the capacity of vehicles, or the volume of goods that are being distributed. So that's another avenue, but definitely there would be again delays in travel if you cannot get a trip or to the desired destination, as we have like stranded people and all of that. So so it will be very challenging, to say the least, if we're getting for the typhoon season this year, with the given parang on top of the pandemic situation that we have. So yeah.
Yeah, thanks for that.
Yes.
Because the follow-up question to that is, aside from cross-border checkpoints, sometimes you would have limitations where people can't cross the border, or they can do so, but you have this 14-day rule or 14-day quarantine rule, and therefore they won't be able to travel further. That's a possibility. And so if you have those situations, how would one try to get away from it? I mean, yes, you can have exemptions, but I guess that's the answer. You can have exemptions, but if beyond exemptions, what other ways would there be?
Yeah. To be Yeah. To be honest, yeah, I guess what we're seeing is that it's already tough during normal times, and so it would be even more complicated, no, with this, but we can see that, for example, like in the sorry, yeah, but in like in the Rizal Stadium situation, they sort of sacrifice the COVID safety precautions, di ba, to parang to surmount the logistics challenges, and this could happen, right? So what could happen is that, for example, sending of relief goods would actually transmit the virus as well to these areas, and have people in crowded places like evacuation centers would also increase the transmission of the virus, and so that parang we cannot solve both problems at once. So the more urgent one gets prioritized, and then we suffer the consequences for the longer term, unfortunately. But of course, yeah, scientists, we would try to we would of course want to like optimize like both, right, and try to see if that's if there's a possible like a middle ground or solution.
Right. Yeah,
Mm-mm.
I guess
But in practice,
something
yeah.
that, yeah, something that would have to be explored would be if there
Mm,
are really alternate ways of framing the problem, and therefore not using the standard solutions that we now have. Uh,
Which is, yeah, which means we need to think outside the box, because these are parang unprecedented challenges as well.
Okay, so in the chat box, actually, there's a follow-up question for you before I switch to Damien again, and also to Alva, which is for Reina, could the high clustering coefficient of the network be a factor in the observed similarity with a small world network? And that calibrating your synthetic small world network to match the empirical clustering coefficient of your empirical network result to a closer fit. That assumes that the traffic network form clusters due to urban areas.
Mm, very interesting. We haven't really looked into this, uh, but I take it as an interesting direction. Yeah, the idea is that you can see if you can calibrate our synthetic small world network to match better the Visayas transportation network. Um, and yes, I imagine that could be possible because we just used like random and arbitrary. Well, we do random network generation and arbitrary um, sort of um, well, um, or like the default setup, and you can of course the idea is you can, if you can calibrate it somehow, then you can uh, get a better fit. um, so yeah, thank you for that idea, Ivan.
Thanks. This one's for Alva, and I've been wondering about this. Alva, how we've been hearing about cytokine storms or cytokine storms.
Yes.
How do they play? How do they appear in in the game model that you have?
All right. So a simple answer would be for the game model, it does not. It will not. Mainly because the data that we used for this does not involve this cytokine storm. Now, let me discuss how this happens. So a cytokine storm happens when you have these pathway, the necrotic pathway. So you have a lot of ITMs in the system that your body goes into haywire. So it goes into overdrive, right? So what this does is that the neutrophils just keep on going into necrosis, which further aggravates the inflammation, and more of these pro-inflammatory cytokines are produced, and this is what you call the cytokine storm. So to answer your question, what could probably stop this? Um, is a proposal that is being done now in Amsterdam. So what we're trying to do, so this was also part of my dissertation, is to inject this so-called alkaline phosphatase. So alkaline phosphatase is an enzyme that was actually not really known for its inflammation properties, anti-inflammation properties, sorry. And now they're trying to do these trials on some COVID patients in Amsterdam, and we're still waiting for the results on that.
Excellent. Thanks, Alva. There's one follow-up question for you from Joe Cruz. For Alva, in your evolutionary game model, you optimize P with respect to one player, but I do not notice that you optimized with respect to Q for the other player. Please comment.
Yes, because it's a symmetric game, so it doesn't matter if you're player 1 or player 2. So if I optimize, say, for one player, it also means that I'm also optimizing for the other player. So this optimized population would actually be P is equal to Q. So that's why I did not mention this Q already. So because they're equal. Anyway.
Okay, thanks, Alva. And one more question for Damien, also from Joe Cruz. In your automata model, you have I+1 on both sides, not the usual way. Please comment on how this is done.
Let me just look at my slides. So I+1 in both sides. I think he is referring to something that looks like this slide. So all it's saying, for example, if you have in your deceleration rule, what this is saying is if your supposed next velocity is, so you're taking the minimum between the headway and your supposed next velocity after doing the first two rules, and you just take the smaller one. So think of it just as some sort of temporary state of the velocity t+1 before you finalize it. So you're choosing between two possible outcomes. It's not really that it depends on itself. It's more of just a notation sort of thing. I hope that answers your question and that it's not too confusing.
Thanks, Damien. And there's one question on the screen, on the chat box from Denny, and I think you've answered it. What boundary conditions are you using?
Yeah, so I answered Denny in the chat. We're using periodic boundary conditions. That is, the two ends of the road are connected together as if it's like a huge circle. But that doesn't limit this model from using periodic boundary conditions. It just makes it easier to analyze these results. So you could have open boundary conditions as you would have, say, in real traffic, where your road is a straight line and then you have a source and a sink direction. But we didn't do that for our analysis.
All right, thanks, Damien. And so now I'd like to thank Reina, Alva, and Damien for the first part of our talk. For our first part of our session. Thank you very much. And we now actually have to move on to the second part. So if they could stick around, maybe they could also still answer messages from the chat box, but probably they need to get coffee right now or drink something.